Good morning, students. Today we will start wave optics. You see here, wave optics. So before that, we have completed ray optics. In ray optics, we have studied light travels along a straight line. But you know, as light is an electromagnetic wave, it is also propagating in the form of wave. How it is propagating? Now, you see here, suppose on the surface of water, I will put a stone. If you put a stone, then what happens? Around that, the wave is propagating on the surface of water in all directions. Like this, if you consider this a point source, from this source, light is also traveling in all directions. That traveling is in the form of wave. For example, you see here, suppose I am considering a point source. As you know, from ray optics, light is traveling along a straight path like this in all directions in the form of in the straight line, that you know in ray optics. But in wave optics, you consider light is traveling in the form of wave like this. In all directions, it is traveling in the form of wave. It is traveling in the form of wave. Now consider, suppose along this direction, this is one crest, one trough, combined to form one wave. This is having phase pi, this is having phase 2 pi. Here also for this case, one crest, one trough, combined to form one wave having phase 2 pi. Here also you consider one crest, one trough, combined to form one wave, this phase 2 pi. You consider these points are having same phase. Let us join these points. If we join these points, then you are getting a surface. That surface we called as wave front. Okay. Similarly, you can consider also, suppose from this point you consider, suppose another wave start, one crest, one trough. That will constitute one wave. From this point also, one crest and one trough. That will combine one wave. From this point also, one crest and one drop, combined to form one wave. Let us join these points. Then you are also getting another wave front like this. Complete. So you are getting several wave fronts as light propagates. You know, as compared to just like in case of the water, when you put a piece of stone on the surface water, water is disturbed. That means wave is propagating on the surface. Like this, your wave is propagating in this manner. Now, this surface is generally spherical in shape in 3D. This is 2D, but in case of 3D, it is spherical in shape. That we call as the wavefront. Now, let us study the properties of wavefront. First property you know. Remember, in a particular wavefront, all particles are having same phase. That means this point, this point, this point, this point, this point, all the points on a particular wavefront are having same phase. Second point you see here, this is the direction of propagation of light and this is the surface wavefront. What is the angle between them? 90 degree. The second point is the direction of propagation of light is perpendicular to the wavefront. Then third point you see here, this is one particle, this is another particle. You see here, for these two particles are vibrating in same phase in two consecutive wavefronts. In two consecutive wavefronts, if particles are having same phase, then this distance is the wavelength of the wave. That means you will compare one crest, one trough, combined to form one wave. This is one wavelength. Completed with the third point. Then the fourth point, you see the shape of the wavefront depends upon the nature of the source. Nature of the source means, you see for this case, what is the source? It is a point source. If it is a point source, the wavefronts are spherical in shape like this. You can draw also here also another wave like this. Several wavefronts you can draw. So the wavefronts are spherical in shape for point source. If it is an extended source, then what is the shape of the wavefront? You see, if it is an extended source like this, imagine here, suppose this is an extended source, light is propagating all direction from this point, this, from all points, light traveling all directions. So I am drawing that point here. Suppose here light is propagating in all directions like this. From this point also light is propagating in all directions. From this point also light is propagating in all directions. Okay, and you join the surface. What we are getting? We are getting in the form of a cylinder. This is the extended source. As light is propagating all directions from that extended source, so we are getting the shape of the wavefront is cylindrical action. Complete. And then if light is present at infinite, means if source is at infinite or light is coming parallel to each other, then what happens? If light is parallel to each other, then we are getting plane wavefront like this. We are getting plane wavefronts. This is one wavefront. You can draw here also another wavefront. So if light is parallel to each other or the source is an infinite, then we are getting the wavefronts parallel to each other as well as perpendicular to the direction of propagation of light. That means you see here this plane, the direction of propagation of light, then wavefronts are like this, perpendicular. This is the plane, one plane, another plane, like this. Several planes are there. Planes are parallel, but the planes are perpendicular to the direction of propagation of light. Complete.